Hello, this is Miss Brubeck, and these are notes on domain and range. It's also the lesson 6-3 notes. So there are two definitions that you need to have memorized, and those are domain and range. Domain is the input or x values of a function, and range is the output or y values of a function. So when you think of a function machine, all right, whatever number you're inputting, that's your domain, and whatever number you're getting as an output, that's your range. Right? So the domain is the number that you input into the machine. The range is the number that comes out. It's your output. Domain is also known as all of the x values of a function, and range is also known as all of the y values of a function. So when we're looking at these two examples, I went ahead and wrote domain and range, the definition, so we don't forget what they are. And I went ahead and wrote x comma y like on top of all of our points, so we just have that easier to see. So the domain is all of the x values. So here, 1 is a domain, 2, 3, 4, and 5. That is your domain. So domain is all of your x values, and we put them in a parenthesis. And the reason we do that is to just show that it's contained. Like these are all of our x values, these are it, there's no others, so we put it in a parenthesis. Then we have your y values. That's your range. Your range is your y values. And so range is all of the y values. So for this one, your range is going to be 1, 2, 5, 10, and 15. That's your range. That's all you do. For the one on the right, your input is your domain. So that's our domain. So all the values that are your input, that is your domain. And those values are going to be 10, 20, 30, and 40. That's your domain. Your range is all of the y values, or it's also your output. The range is the output. So here our range is going to be 15, 25, 35, and 45. And that's it. That's your range. If you need more time on this slide, go ahead and pause the video because we are going to move on. So here we have a table. All right. Remember that domain is all of the x values. So when we're writing the domain, we're going to write down all of the x values. And they are -1, 0, 1, 2, 3, 4, and 5. That's our domain. Then our range is all of the y values. So we're going to write down all of our y values for our range, and that is 18, 11, 6, 3, 2, 3, and 6. That is our range. All right, again, if I'm moving too fast, pause the video because I'm going to move to the next slide. Now we have a graph and we need to find the domain and range. So the first question it's asking us is this a function? And we can tell if it's a function if we draw vertical lines through our graph and it only hits the graph once, then it is a function. If it hits more than once, then it's not a function, but this is going to be, yes, a function. So that is a function. Oops. That is a function. Oops. That is a, sorry about that. That is a function. So we'll write, yes, don't know what happened, but I think I tried to do too many things at once and my Jamboard had to reload. Sorry about that. So that is a function. Now to do the domain we have to look at all of the x values, okay? All of the x values. So we're going to look at the x-axis, and what you want to do is you want to draw a line on the left side of your graph and the right side of your graph, and you want it to hit the x-axis. So here it hits the graph at -2 and +4, and we always read the graph from left to right. So our domain in words is going to be -2 to 4. Then the way you write that in notation, it's super easy. You just write it as a parenthesis, -2, 4, like that. Really easy. But what's hard about this part, the domain, is you have to write it as an inequality. And so that means you need to write inequality signs like this. And we're going to use x because domain is x. Domain is our x values. And then you put your -2 on the left and your +4 on the right. So that takes a little bit of time to get used to. Now, as we've talked about, the range is your y values. Your range is your y values. So what that means is we are going to go to our y-axis now, and we are going to draw lines on our y-axis at the top. Let me make a bit thicker line. At the top and at the bottom. And we read our graph bottom to top. So it hits here on the y-axis at 0, and it hits here at 3. So in words, our range is going to be 0 to 3. And then when we write that as notation, it's going to be 0, 3. And then when we write it as an inequality, it's going to have, again, the inequality signs. But this time we're going to use a y because range is y, not x. And then we're going to keep the numbers just like before. 0 goes here, and 3 goes here. All right, if I went too fast, go ahead and pause the video because I am going to go to the next one. So this is, it asks if it's a function. It is a function because every time you draw that vertical line, it hits the graph only once. So that is a function. Now, again, we're going to do domain first, and domain is our x values. So again, we want to draw lines on the left and right side of our x-axis. But this time I want you to notice that there's arrows. Not points, arrows. So arrows mean that the graph goes on for literally forever. It means it doesn't stop. It's going to go past the end of this graph, and it's just going to keep going like that. Okay, it's going to keep going on forever. So when that happens, instead of saying that it hits here at -5 and +5, instead we're going to say infinity. And so in words, we're going to say negative infinity to positive infinity. And we say negative infinity because on the left side is negative numbers, on the right side is positive numbers. Now, how you write that in notation is a little bit different. To write an infinity sign, so we're going to have a negative sign, and then to write an infinity sign, it's like a sideways 8. It's very hard to do on the Jamboard. That one's not bad. And then we'll have a positive infinity. That one could be better, but I don't want to rewrite it. So that's how you would write the domain, put your parenthesis, and then the way you do it as an inequality, same idea, but this time, like last time, we're going to put the inequality signs. So we're going to have our, ooh, that's a good infinity sign. We're going to have our inequality signs, we'll have x, and then we'll have our positive infinity. Oops, I forgot to put the inequality sign. Sometimes I forget to do the second one. Inequality sign, and then our positive infinity. Okay, now for the range, we're going to use, I'm going to use blue, and we're going to draw lines across the y-axis for the range. Let me make that a little thicker. So here is where it hits on the bottom, and then up here it hits up here at the top. So that's going to be 0 on the y-axis, but then it goes on forever. So it's going to be 0 to infinity. So in words, we're going to say 0 to infinity. And then the way we're going to write that down is we're going to have, in notation, we'll have 0, comma, an infinity sign, and then we'll put our parentheses. There we go. And then the range, we'll do the same idea, 0. We'll have our infinity signs like we did, or our inequality signs, sorry, like we did before, but this time we'll use a y, and then we'll put the infinity at the end. So if you need more time on this slide, go ahead and pause it because I am going to move on to the next video. This graph is again a function. Every time we draw a vertical line, it's only going to hit once. And for domain, remember, again, domain is our x-axis. All right, x-axis. So when we're looking at this graph hits right here at -4, but as you can see again, there are arrows, and so this is going to go on to infinity. So our domain in words is going to be -4 to infinity, and then to write that in a function notation, it's going to be -4, comma, infinity, and then we also have to have our parentheses. And then as an inequality, it'll just be -4. Oops. -4. Make our inequality signs. Make sure you use x because we're talking about domain. And then another, oh, not my best inequality sign, but another inequality sign. Now I'm going to go ahead and erase this to make it a little bit more clear for our range. For range, I will use blue. And our range, we want to cross the y-axis. So the y-axis, we're going to cross right here and right here. And remember, there is an arrow here. So the lowest point this hits on the graph is at -2. And then it looks like it hits here at +2, but it's actually at infinity. So our range is going to be -2 to infinity. And then the way we're going to write that in notation, we'll say -2, comma, infinity. And then as an inequality, we'll again say -2, but we'll draw our inequality signs. Make sure you use a y because our range is the y-axis, inequality sign, and then our infinity. If you need more time on this slide, make sure you pause the video because I am moving on. Now this one says, this is a little bit different. It says if you have f of x equals 2x plus 1, and it gives you the domain. It gives you the domain right here. This is the domain. It's asking what is the range. So if you remember, domain is input. So we need to find the outputs. We need to find the outputs. Okay, so we're going to take our function. And first we'll do the 5. Everywhere we see an x, we'll input a 5. And so that is going to be 2 times 5 is 10 plus 1. So our first number is going to be 11. Then we'll do it again, and this time we'll do it for the 25. So everywhere we see an x, we'll insert a 25. And 2 times 25, that's 50. And then plus 1 is 51. So that output is 51. And then we need to do one more, and that's for the number 50. So everywhere we see an x, we'll insert a 50. And 2 times 50 is 100. Plus 1. And our output's going to be 101. So when we're writing the range, we're going to say that the range is 11, 51, and 101. We're going to say the range is 11, 51, and 101 because this was our answer, this was our answer, and this was our answer. All right, if I went too fast on that slide, pause the video because I am going to go to the next one. This is the same idea. We're using this function. They give us the domain, and they want to know what is the range. Oh, that's a lot of numbers. Let's see. So if we had f of x equals 3 plus 2x, and we insert the 15, or sorry, no, the -13, we'd get 3 plus 2 times -13, and then you would just simplify that. So you do the 2 times the -13 first. 2 times -13 is -26. And then if we do 3 minus 26, we would get -23. And so we would just keep doing that. Okay, our range would be -23, and then you just keep going. You'd then plug in for the next one. You'd plug in the -3, the 6, the 10, the 13, and the 18. I'm not going to go through all of that, but that's how you would do that problem. All right, that is it. If you have any questions, let me know.